Okay, everybody, today we are going to be discussing electron configuration. And what electron configuration is nothing more than an account of where electrons reside in an atom and its energy shells, which we'll get into later. Now, it's relatively simple, but what you have to understand is that you have to understand the basic structure of an atom in order to understand this video. So if you haven't seen my, introduction to chemistry video that I've done before, please check that out before you check this video out. Okay, now what I want to first cover here is that an atom, of course, as you know, and if we picture this, an atom has electrons spinning around it, okay, and this right here is the nucleus of an atom. Right, the electrons are spinning around here, and what this means is that electrons are orbiting here around this nucleus of an atom. But what we often aren't shown when looking at the structure of an atom is that there are kind of fixed quantum energy levels in which electrons can reside. Okay, consider this the nucleus right here, alright, and consider these circles that I'm drawing energy levels, alright, and every energy level holds a set amount of electrons, and by knowing these energy levels and how many electrons each one can hold, you can understand exactly where, in which energy level, for example, the electron is in any given atom. So if we look at our periodic table, and as I've explained before in my other videos, every element has an atomic number at the top upper left corner, and an atomic mass at the bottom left corner. And if you don't know what these values mean, you need to check it out in my other video, because I don't have time to explain that one right now. But as I've said before, the atomic number at the top left-hand corner is going to tell you two things: how many protons and how many electrons are in that atom. Okay, so for an atom of sodium, which is Na, which we're looking at right now, you would have 11 electrons in that atom. Okay, for, I don't know, iron, which is symbolized Fe, you would have 26. For oxygen, you would have 8. Okay, for magnesium, you would have 12. Okay, so let's take magnesium for an example. Okay, alright, so magnesium, which is Mg on the periodic table, has 12 electrons. That's the symbol for electron, an E with a minus up at the top. Okay, so we know that an atom of magnesium has 12 electrons. Where are these electrons situated on their respective energy levels circling around the nucleus of an atom? Okay, well, we happen to know that each energy level can hold a certain amount of electrons, alright? And for our purposes, there are more, but for our purposes, we're only going to go out to 4 energy levels. Okay, so that's 1, 2, 3, and 4 energy levels, alright? These energy levels can also be called shells, alright? Shells. And every shell can hold a certain amount of electrons, right? The first shell can hold 2 electrons, alright? Second shell can hold 8 electrons. Third can hold 18. And the fourth, I'm trying to remember exactly how much the fourth can hold. 34, I believe. I could be wrong on that, but it holds 34 electrons, I believe. Okay? So, given that knowledge, we understand that each level can hold a certain amount of electrons, but what we don't yet know is that each shell has a subshell. Okay, and the subshells the shells are denoted by numbers. You have shell 1, shell 2, shell 3, shell 4, but the subshells that make up a shell are denoted by letters, okay? And there are several different kinds of subshell letters that we're going to be using today. We have an S subshell, we have a P subshell, we have a D subshell, and we have a F subshell. Okay? S can only hold 2 electrons. So, given that knowledge, we should know that the first shell that can only hold 2 electrons is only comprised of an S subshell. So you have one always has only an S subshell. Okay? The second shell has an S and a P. P's can hold 6 electrons. So, if we look at our value here, the second shell can only hold 8 electrons. The reason it can only hold 8 electrons is because it has a S, which holds 2, and a P that holds 6. 2 plus 6 is 8. Alright? This, of course, can only hold 2, so 2. The third subshell has a S, P, and a D subshell. Okay? D's can hold 10 electrons. Alright? Now, the reason it can hold 10 is because the S can hold 2, the P can hold 6. Oh, I'm sorry. My mistake. Yeah, D's can hold 10, but the third shell can hold